Okay, so when you look at that question, it reads forces 6, 5, 7, 8, 5, and 9 act on a particle in these directions. North 30 degrees east, north 30 degrees west, and so on. So if I draw the diagram and I extract out these forces according to their directions, 6 newtons acts north 30 degrees east, which is that. 5 acts north 30 degrees west, which is this one. 7 acts south 50 degrees west, south 50 degrees east, sorry. This is where east is going. Then now we have 8 south 60 degrees west. From here you're south going to west 60 degrees. This is where the 8 is. So I can find first their algebraic sum, and I get the components of their horizontal and vertical. I can use vectors, whereby I can use x and y to represent the sum of their x components and then the sum of their y components. And remember, we said when you are resolving forces, we shall resolve them to the horizontal, which is the x-axis, and to the vertical, which is the y-axis. So if I start with a 5 has 80 to the vertical. That means if I resolve 5 to the horizontal, I am moving away from the 80. So I'll have 5 sine of 80. Then when I take the 5 to the vertical, I'll be compressing the angle 80. We say when you compress the angle, you use cos. So this is cos of 80. Because they are vectors, you go on adding the different vectors for the different forces. 6 sine 30, 6 cos 30. Why is 6 sine 30? It's because 6 was at 30 degrees to the vertical. When you move away from the vertical to the horizontal, you're moving away from the angle, and we use sine. When you move to the vertical, you compress 6 to the vertical, you're compressing the angle, so we use cos. Next we have plus 5 sine of 30. Why am I saying 5 sine of 30? 5 sine of 30, I'm moving away from the angle, we use sine, but it's going to go in the negative x-axis, so this will be a negative. Then I'll have 5 cos of 30. Next I'll have 8 with the 60. Resolve the 8 to the vertical and to the horizontal. It will be in the negative because it is in the third quadrant. The third quadrant has a negative x-axis and a negative y-axis. So we shall have plus negative 8 sine of 60, negative 8 cos of 60. Plus 9, also in the third quadrant, negative 9 sine of 40, and then negative 9 cos of 40. Then lastly we have 7 taken to the horizontal, which is the positive x-axis, and the vertical is the negative x-axis, y-axis. So we shall have 7 sine of 50, negative 7 cos of 50. Then with that, we can press our calculator. And when you press your calc, you'll see that when you compute that, the first result, you need to, if you don't have a calculator, you can download one from Real Max Scientific Calculator. You go to the Google Play Store and then you download that app for the calc. So x gives us, if I compute this, will give me x is actually negative 3.0, negative 3.01532. Then my y, if you compute the y, we shall have brackets. If you compute all this, it gives us a negative 5.0, so negative 5.02033. Now, this is the algebraic sum of all these forces resolved. The algebraic sum of all these forces resolved, they're asking us to get an additional force, which makes them become in equilibrium. So, it means for equilibrium, xy has to be added to another vector AB to give us 0, 0 as the resultant force. So in that regard, what will happen is you add this vector here, which is actually giving us negative 3.01532, negative 5.02033. When you add the two together, we shall get AB is equal to 0, 0. We add the corresponding vectors in the X or in the I together, and then those in the J also together. So we shall have negative 3.01532 plus A is equal to 0, and thus A is 3.01532. Then negative 5.02033 plus B is equal to 0. My B will become positive 5.02033. So finally, our vector, you can call the vector maybe V or any other force. Our vector is 3.01532 and 5.02033. Because the question wanted the force, they never wanted the vector, we need to get the magnitude. So to get the magnitude, what happens is the magnitude of this vector V is the square root of 3.01532 squared plus 5.02033 squared. And then we can compute and get the magnitude of this expression. The best option of having the vector format is that the vector talks about the magnitude and the direction. Because both of them are in positives, it means it is in the first quadrant. But with this, you get the magnitude and you get the exact force you need. Then you can draw an appropriate right angle triangle to tell you the direction where it will be acting. So this is where the magnitude of V would be. Then you can find theta. From this is 5.02033, as this one is 3.01532. Thus, tan of theta shall give me 5.023 divided by 3.01532. Then you press the calc by saying shift tan inverse of the whole fraction, then you would get the direction in which that force actually is acting. With that, you would have confirmed the force which is necessary to be added onto these forces so that the entire system goes to equilibrium. And remember, we said for equilibrium, the algebraic sum of forces in the horizontal is 0. Likewise, the algebraic sum of forces in the vertical is also 0. So, with that regard, we can have this done in vector form. Other people can resolve them by just getting the sum of the forces in the horizontal, or others can get them in the form of getting sum of forces in the vertical. Then all of them, they are equated to 0. But with this, as long as we are dealing with more than at least 2 or 3 forces, I've said we are dealing with more than even 3 forces. So these are how many? There are 6. We have even included one more, which makes it go to equilibrium, which is the 7th. So we can handle any number of forces by resolving, by using the vectorial approach, by using the analytical approach or the analysis technique, and so on and so forth. So with that, we can have that illustration. Remember I said, you can go ahead and pause in case there's something you want to take a keen look at, take a screenshot, so that you can have more attention to some of the concepts. And remember, if you have a challenge, don't hesitate to reach me out in my inbox via my social platforms. You can go to WhatsApp, you can go to Facebook, you can even visit my YouTube channel and see how best you can get into contact with me so that I can guide you more on such illustrations. So let's have another illustration. This one is going to be a reminder on the concept of having at least 3 forces where we have various options to use. So our illustration will say, example 2, a particle of mass 5 kgs suspended by 2 strings of length 7 centimeters and 24 centimeters attached to 2 points. Attach to 2 points in the same horizontal. 25 centimeters apart. Find the tensions in the strings. Find the tensions in the strings. Now, to start with, we have a particle. If you have a particle, we can have something like, let me show you something which could interpret what the question is trying to say. If I have this bag, the bag can act like my particle. Then I have my 2 strings holding the bag. So my hand, my fingers are 25 centimeters away. Now the bag is being held in the middle, and there are forces acting on the bag. That's why you see the strings are taut and straight. So they can ask you to find the tensions in these strings. You see that when you reduce the distance, the bag goes lower. When you increase the distance, the bag rises. So this is trying to illustrate what exactly this question is trying to put up. So here we are. We have 2 points. And these 2 points, we have a particle. We have a particle placed here, and this particle has 5 kilograms. And we have tension. We can have this as tension T1. We have here tension T2. The distance between them is 25 centimeters. One of the strings is of length 7 centimeters, and the other is of 24 centimeters. Now, for a smart student, if you're good at Pythagoras theorem and you've investigated some of these hypotenuse, adjacent, and opposite, if you square 24 plus the square of what? Of 49, you will see that you get 576 for 24. 576, if you add on 49, the answer is 625. So 625 gives you, by use of Pythagoras theorem, it means that if this is a right angled triangle, then the square of this plus the square of that gives you 25 squared. So the hypotenuse is 25. So straight away one can be in position to identify what exactly this triangle is all about, and this makes a triangle of 3 forces with the angles which can be determined. If this is theta, this can be alpha. So one of the methods we can use is Lamy, the other method is resolving. So I'm going to take you through both methods. So method 1 is to resolve horizontally. So in the horizontal, the angle down here will be alpha. Also the angle down here will be theta. Z angles. So if I resolve to the horizontal, I'll have T2 cos alpha. To the vertical, I'll have T2 sine alpha. To this horizontal, I'll have T1 cos theta. In the vertical for this one, I'll have T1 sine theta. Now, if the particle is being held like that, it will be in equilibrium without even telling you. They are not telling you that this bag is moving up or down. So we are just holding the bag like this. It means the bag is in equilibrium. If it's not moving in equilibrium, it's not moving up, it's not moving where? Down. Neither is it moving to the left nor to the right. So it means the sum of forces in the left is equal to the sum of forces in the right. And then the sum of forces which is upwards is equal to the sum of forces which is downwards. So horizontally, all the algebraic sum acting on the forces in any direction is 0. So let me first consider horizontal. I'll have T2 cos alpha minus T1 cos theta is 0. Why do I say minus? It's because this is in the positive x-axis, this is in the negative x-axis. Then for vertically, T1 sine theta plus T2 sine alpha minus 5g is 0. Why have I considered it like this? It's because when you look at T1 and T2, they are all facing in the same direction after resolving. So that's why I've added them. But you can get these trigonometrical ratios. For example, cos alpha is equal to adjacent over hypotenuse, which is 24 out of 25. Sine of alpha is opposite, which is 7 out of 25. Then also we can get cos theta, which is 7 out of 25. And we can get sine of theta, which is actually equal to 24 out of 25. It means cos alpha is equal to sine theta. Likewise, cos theta is equal to sine alpha. So we can have these illustrations and we substitute, and then we see how we can best solve these simultaneous equations. So when I substitute here, my T2 cos alpha is 24 out of 25. It's supposed to give me T1 times 7 out of 25. I can divide the 25, and thus my T2 is actually equal to 7 out of 24 of T1. I can call this equation star. These ones are my equation 1, equation 2. Then from Roman 2, we can have T1 times 7 out of 25 plus T2 times sine of alpha. T1 is sine of theta. This is T2, sorry. This is T2. Then for T1, it is sine of theta, which is equal to 24 out of 25. And this is supposed to give us 5g. That is, if I move the 5g across the left-hand side. So substitution for T2, this can give me star 2. So put star 1 into star 2. Put star into star 2. We shall have, when we put T2 here, we shall have 7 out of 24 times 7 out of 25 T1 plus T1 times 24 out of 25 is equal to 5g. When you look at this algebra, we shall have the 25 can cross over. Then we shall have 49 T1 plus 576 T1 is equal to 125 G. All this is over now 24. I have cross multiplied the 24 all through. Then I simplified the 24 times 24 to get the common LCM. So more algebra on that. The numerator gives us 576 plus gives us 625. So 625 over 24 T1 is equal to 125G. So T1 is 125 times 24 G out of 625. By 25, 25, by 25, 5. So this will give me 5 times 24 is 120 G out of 25. Okay, by 5 here once, by 5 there 5. So the best answer would be 24G out of 5. If G is 10, you can substitute and get the answer. If not, if G is not 10, then it can give to you in the form of the standard G, which is 9.8 or 9.81. Targeting T1, we can get T2. T2 shall be 7 out of 24 times 24G out of 5. I can lose the 24 by division. Then my final answer is 7G out of 5 newtons as my T2, and this one as my T1. So with that, you are using the method of resolving. Now, I also wanted to illustrate this method of Lami's theorem to remind you how we can go about it. Remember, Lamy talks about 3 forces in equilibrium. So this is my T1, this is my T2, there is 90, we have 5G. Because of this shape here, this makes 90 degrees, so the whole of this angle will be 90 plus alpha. Then the whole of this one will be 90 plus theta. So for Lamy's theorem, it states that 5G out of sine 90 should give us T1 out of sine of 90 plus alpha should give us T2 out of sine of 90 plus theta. Sine of 90 plus an angle, for example, sine of 90 plus 30 is sine of 120. Sine of 120 is the same as cos of 30. So it means sine of 90 plus alpha is actually equal to cos of alpha. So I'll have 5g over 1 is equal to T1 over cos of alpha. T1 is equal to 5g cos alpha. Cos alpha is 24 over 25, which is 5g times 24 out of 25 by 5, and the answer will be 24g out of 5 newtons, which is the same answer. Then lastly, sine of 90 plus theta is the same as cos of theta. Therefore, T2 over cos of theta will also give you 5g over 1, because sine of 90 is 1. So finally, still T2 shall be 5g cosine of theta, but cos of theta is 7 over 25, hence 5g times 7 over 25 by 5 once by 5, 5. Still T2 will give me 7g out of 5 newtons. And it is the same answer. So I have reversed this approach of learning, and I've tried to show you that this number can be done at least 2 ways. One, you can resolve by taking horizontal and vertical components. Then 2, you can use Lami's theorem because it has 3 forces. And with that, allow me stop there for today, because I had promised that we are going to still do some more illustrations on numbers of equilibrium of forces. And I trust that with these illustrations, you can meet some of more of these numbers in understanding mechanics by Sadler and advanced level mathematics, that is by Bostock and Sadler, which has both statistics and mechanics. So you can visit those books. And this is applicable to both students of mathematics and those of physics in the area of mechanics. So I trust with this you can be able to visit more numbers and try them, and don't hesitate in case of any challenges to come out and reach out to me for more help. Remember to keep sanitizing if you go out, if you have to go out. Remember to put on your mask if you have to move out and go to public. Today I forgot my mask, but like I always do, I always try to remind you about the mask. So please remember to put on your mask everywhere you go, and remember to sanitize from any points which are having the points of sanitizing. My name is still Hamza Rwama, and I've been your teacher for today, which is in the field of physics and math, in the area of mechanics. God bless you. We'll meet next time.